Recording. All right, this is Algebra 2, Test 3, Lessons 1 through 15 review. The date is October 19th, 2020. It's a Monday. This is third period. I don't know if I have any other numbers to add to this. My social security number is not going to be on the video. Okay, question number 8. Question number 8. So what it wants us to do is it wants us to find the determinant, set the determinant equal to 66, and then use that to solve for x. So I'm going to do this just in here. I know that may be kind of confusing, but rather than flipping from document to do this, what we do first is we've got -4 times -9 minus -6 times x plus 6, okay, equals 66. -4 times -9, what is that? That's 36, right? Okay, 36. Let's see, if I don't have it wrong, I should distribute the -6 to the x and the 6. So that's minus, let's see, minus -6x minus 36. Okay, now here's the other thing is that I have to distribute that negative to all of the terms in here. Okay, so that gives me 36 plus 6x plus 36 equals 66. Okay, so there's a double distribution in there. Okay, so we get 36 plus 36 is 72 plus 6x equals 66. Subtract 72 from 66. Okay. Okay, what's 66 minus 72? -6. -6 divided by 6. So x equals -1. Did I get the right answer? Awesome. Okay. Does that make some sense to us? Do we understand how to find the determinant of a 2x2 matrix? This one is a little bit more confusing because I had to distribute and distribute again, okay, to simplify. Questions about that? No? Okay. So, I mean, this is all just going to be in the video. I'm not going to be sending out any real documents to go with this because I'm going to clear this ink so that I can go on to other questions. Does that make sense? Okay. All right, after number 8 was number 16. Okay, 16, a subway pass costs $20 and $1.50 is deducted from the balance on the pass every time you use it. We want to write and graph an equation to represent this situation and graph it. Okay, so the cost is $20, right? Cost is $20. What happens every time I use it? It goes down in value. So if I used it one time, right, it would be 1.5 times 1, right? If I used it twice, right, it would be, you know, -1.5 times 2 times 3 times 4. So really what I would have in here is I would have -1.5x, correct? Because we don't know how many times we're going to use it. All right, now if I wanted to just solve for y, what would I do with that 20? All right, I would probably, let's see, subway cuts, use it, right, and graph an equation. Yeah, hopefully I don't have that wrong. Okay. What does it have for the answer on the equation? Did I get this right? It says plus 20. Okay. You have to start with your 20. Okay, that's fine. I'm fine with that. Okay. All right. All right, so from there, okay, we'll add 20 over here. We've got our y equals. Okay, from there, when we go to graph it, okay, it's really just a simple matter of coming up 20, because, right, we're starting with 20 and we're dropping. What is my slope on that, though? But what's easier than going down 1.5 over 1? Going down 3 over 2. Right? Going down, because negative 1.5 is the same as negative 3 halves, correct? So as much as possible, I want my slope to be a fraction, even if it's an improper fraction. Okay? Are we good there? All right, so down 3 over 2, down 3 over 2, that type of thing. Okay, we should get a line that looks like that. Questions on that? Sorry, hopefully I didn't mess you up with the whole negative 20 plus 20. Okay, let's see, that's 16. From there we have 19. Oh, Kramer's rule. Oh, how we love thee. Okay, so I'm going to solve this using Kramer's rule just because I feel like it's something we haven't had a whole lot of practice with in terms of being able to understand it. So, do we want to solve for x or y first? X. So we're going to solve for x first. Okay? Now, the easiest determinant to do is always the denominator determinant. Okay? What's the denominator determinant here? 7, negative 4, 5, and... Okay, does everybody understand where those numbers came from? No. Okay, I got a no. All right. Your denominator determinant is coming from those 4 numbers in those 4 orders. Okay? 7, negative 4, 5, negative 3. We got that? Okay, so that cleared up some stuff for us. Okay. Because we are solving for x, okay, when it comes to the top determinant, I take my solutions and I substitute them in for those x values. So instead of using 7 and 5, I'm going to use 6 and 2. Okay? But I'm going to continue to use negative 4, negative 3 for the y values. Okay? So when you're solving for x, you sub in for x. Okay, do we understand that part of it? Now, hopefully we understand how to do a 2 by 2 determinant. We're taking 6 times negative 3, which is negative 18, and we're subtracting 2 times negative 4, which is negative 8. So we've got negative 18 plus 8, which is negative 10. Okay, over here, we've got 7 times negative 3, which is negative 21, minus 5 times negative 4, which is negative 20. So we have 21, negative 21 plus 20, or negative 1, which gives me an answer of 10. So the x value there is 10. Was that easier than what it was before to understand that? Okay. Now we're going to solve for y. Okay. Now here's the handy thing about the second time you do it. You don't have to do the denominator again. What do I know the solution for the denominator is? No, it's negative 1. Okay? The denominator is not going to stay the same because those numbers don't change. Okay? All right, so I'm still going to get the same 7, negative 4, 5, negative 3 for the denominator. I don't need to go through the multiplication and subtraction and combining like terms all over again. All right? But because now I'm solving for y, what do I substitute? Here, let's use the same color. Okay, what do I substitute 6 and 2 in for? My y values. Okay, so instead of having 4, negative 3, I'm going to use 6 and 2. Okay? Okay, and for my x's, I get to use my x's this time. So I get 7 and 5, 6 and 2. Okay, we already know this is negative 1, so we'll keep that going through there. 7 times 2 is 14 minus 5 times 6. Okay, 14 minus 30 is what, negative 16? Negative 16 divided by negative 1, 16. So, let's see. They just say use Kramer's rule to solve. X is 10, Y is 16. Did I get those right? Awesome. I'm really good at math. Oh. All right. Do we understand Kramer's rule better now than we did? Okay. Did it answer some questions for us? Okay. So denominator matrix is just my x's and y's. If I want to solve for x, I substitute for x. What am I substituting for x? The solutions, right? We put the solutions in for x. When I want to solve for y, I substitute the solutions in for my y values, put the x's back. I mean, kind of, but it's using the determinant in substitution to solve. Okay, we good there? All right, hopefully that's a big help for us. There are other ways to solve those questions, but, you know, because that's what it's asking, that's what I'm going to show you. If you use one of the other methods, say you solved by graphing, or you solved by elimination, or solved by substitution, or one of a number of other ways. Well, let's say you put them into a matrix and solved. Listen, so long as you can show your work and your work is valid, I will give you credit, okay? Even if you didn't solve using Cramer's rule. But I'm just going to show you Cramer's rule because that's what it said, okay? All right, 17. Classify negative 3x squared by degree and number of terms. Well, how many terms does it have? 1, so it's a monomial, right? No, it'll be wrong. It's a monomial. There's a reason that we learn those terms, okay? Now, by degree is the 2, right? 2 tells me it is quadratic. 2 tells me it's quadratic. It is a quadratic monomial. Okay? Am I wrong? Okay. If it was, gosh, I'm trying to remember what the other terms are. You know, if there was 2 terms, you know, 2 terms there, it would be a binomial, right? If there was, let's see, I think that if there's no exponent, then we just call it linear. Okay, I'm trying to think with 3, but you have a whole, let's see, if I wanted to go to this and find out, and you should see this in your answer key. So if this helps, you can find this in your answer key. So it's number 17. Let's say I wanted to go back and I wanted to study to see what other possibilities there are in case it's different on the test. Okay? Notice how it says lesson 11 on 17. So that means I could go over to lesson 11. I'll probably find a chart. Or easier than that, I can go to lesson 11 and look in my notes that I took and find out what all those different things are and examples of those, right? It probably wouldn't hurt me to look at lesson 11 and look at that chart, okay? Does anybody still have their lesson 11 notes with them? Does anybody see that chart where it talks about monomials and quadratics and quartics and quintics and all of that kind of stuff? You find it? Okay. So yeah, so we have degree, number of terms has specific names. All right, so that's not a bad thing to maybe highlight, go back and look at. Okay, we need to look at question number 20. Okay, Cramer's rule again. Do we feel like we understand Cramer's rule enough to skip that question, or do you want to do it again? Do it again. Okay, do it again. All right. So we want to solve for x again first, right? Just so that we're staying consistent. So we got x, we got determinant over determinant. Okay. I always like to do the denominator first because it's the easiest. So what are those numbers here? Okay, I'm just going to tell you what you're going to tell me because on test day, you're going to do what you're going to do, and there's not going to be, 10 other people saying it's negative. Okay, all right, so we got 6, negative 7, negative 5, and 4 up here.
11.
Good.
Negative 11.
Okay.
Negative 7. 4.
Good. All right, you're on a roll. All right. Let's see. 11 times 4 is 44 minus positive 77 because it's negative times negative, right? All right, let's come down here to the bottom. 6 times 4 is 24 minus 35, okay? Okay, 44 minus 77 is probably negative 33. 24 minus 35, negative 11. Okay, negative 11. Negative 33 divided by negative 11, 3. Okay, so x should equal 3. Okay, let's come to y. What do we know our denominator solution is going to be? Negative 11, very good. Okay, now let's set this up for y. What goes here first? 6. What goes here? What goes here? 11. Okay, here? And here? Okay, good. All right, so we carry that negative 11 over. 6 times negative 11. Good. Negative 66 minus negative 5 times 11. Negative 55. Okay, so we got negative 11. So we got negative 66, effectively plus 55, which is negative 11. Negative 11 divided by negative 11 is 1. So y equals 1. Is that the answer? Super duper. All right, are we better yet now? Now Kramer's rule might, that's kind of the neat thing is that whenever we struggle with something like Kramer's rule, if it's been explained a couple of times, like, hey, I get this, like some of you may even get to a point where you prefer to do Kramer's rule. If you understand it and it works, if you understand it better than other ways, okay? All right, 20, last one on our list was 12. Okay. 12. Hannah lives 4 miles from school. Ellen lives 7 miles from school. Write an inequality to represent the possible distances between their homes. Okay, so we want the closest they could live together and the furthest apart they could live from one another, okay? Given those distances from the school. So you might have remembered a question a while back about, Tommy and Sally were standing next to a tree. Tommy kicked the ball, it went this far. Sally kicked the ball, it went this far, right? How close or how far could those balls have been? So in this case, the tree is the school, and their houses are the ball, okay? So let's see. I've already kind of... All right, we got 4 miles. Hannah lives 4 miles. Ellen lives 7 miles. All right, so here's Hannah. 4 miles from the school, right? And then Ellen is what? 7 miles from the school? Okay. So what's the closest they could live together? 3 miles. And that's if Ellen lives here, right? There's your 7, okay? There's that right there. So we know that the distance that they live from each other is either going to be greater than or equal to 3 miles. Right? They can't live any closer than 3 miles. All right? But the other possibility is that if Hannah lives here, what's the furthest away Ellen could live in terms of direction? The exact opposite direction, this way over here, 7 miles, right? Okay? And so we would figure out what this is, 7 plus 4, 11. But they aren't going to live any further than 11 miles away, right? Okay, they can't get any further away than that. Does that make more sense? So to me, drawing the picture helps understand how we come to numbers like 3 and 11 out of that. Okay? Questions there? Are there any other questions from the review that you want to cover? Take a look at what else you missed. Yes. You want to borrow a math book? Yeah, you can borrow a math book. Okay. Remind me towards the end, and I'll get one checked out for you. Okay? Yes? Number 18. Okay? Subtract. Okay, so this is a great question to look at because a lot of people miss this for one very simple reason, and that is I am subtracting all of x cubed plus 3x minus 15 from 6x cubed plus 4x. Okay, which means in order to get an accurate representation of it, I need to distribute the negative to every term, okay, because I'm subtracting all of those terms. So it's really 6x cubed plus 4x minus x cubed, and a lot of people will do that. They'll just drop the parentheses and put minus x cubed plus 3x minus 15 when it's really minus x cubed minus 3x plus 15. And now I can combine like terms. Okay, I've got 6x cubed minus x cubed, which is 5x cubed. I got 4x minus 3x, which is plus x, and I've got a lonely 15 sitting over here with nobody to play with. Poor 15. Okay. Was that, am I accurate in assuming that that was the mistake? Yeah. Yep. I mean, I haven't been doing this a super long time, but I've been doing it long enough to know what people are likely to do. Okay. What else? Places where you don't know how you messed it up. On 4. 4, what is the new amount when 36 is increased by 60%? There is a really, when you're talking about increasing something, you can do this in one short step. You can do this by taking 36 times 1.6, and you'll get it. Why 1.6? Because 1 represents 100%, and 0.6 represents the 60%. Right. If you wanted to, but it doesn't work with decreasing, which is why I don't always. That's why I haven't showed you that. Where I've showed you in the past was take 36 times 0.6, get that answer, and then add it to the original number, which is 36. Okay. But this gets it all in one shot.
That's the way I did it, except I took 160 times 36 and then divided it by 100.
Okay. Yeah, I mean you're taking your percents and you're setting up a proportion to get them back into normal numbers. But it works, yes. If it works every time, great. I'm not gonna throw a fit about it. Okay. But if you get to the test and you do something like that and you make a mistake and it doesn't work, like okay. When it hit my, when I did that, no. All right, other questions? I feel good? Test tomorrow. Number 2, evaluate. All right, so basically on this, let's start by doing parentheses for our variables. All right, we've got x is -2, y is -8, 9, y is -8. My guess is that when some of you go through to do this, you drop your parentheses off, like whenever you're doing it in the calculator, right? -8 squared without parentheses is going to be -64, right? -8 inside parentheses is +64, because a negative times a negative should be a positive. All right, so I should get 64 times 9, okay? Is that? You dropped your parentheses. And I see that mistake being made on tests all the time. What kills you on tests is not normally that you have no idea what you're doing. It's that we make little mistakes like dropping parentheses. Okay? So do I need to go through the rest of it, or does that answer your question? Okay. Anything else? Let's see. I want to pull up the actual test and see. Hold on. Okay. Let's see. Okay, so there's that one. All right. Here's a question that I want us to look at. The question is writing and graphing an inverse variation. Write and graph an inverse variation. Because this is not something I don't write and graph an inverse variation in which y equals and x equals. All right, give me a regular, simple, positive number for y. 3. Okay. Give me a regular, simple, negative number for x. I'm going to say -4. Okay. All right. So what does an inverse variation look like? Y equals k over x. Okay. So if we know this, what we're going to do is we're going to substitute in our numbers. We got 3 equals k over -4. Okay? So far, so step 1, step 2, step 3. Step 3 is solve for k. How do I solve for k? Multiply by -4 on each side, so k equals what? -12. Okay? The final step is write our inverse variation with our constant in our equation. So simply write y equals -12 over x. Okay? And if I could say that our last step is going to be graphing it. All right? Hopefully everybody tomorrow has a graphing calculator, because what you're going to do, okay, is you're going to come over here, you're going to put -12 divided by x. Okay? And you're going to get something that looks like that. Okay? So you're going to pick. Now, there will only be one answer that looks like this, so the graph is less important. Okay? Because it's going to be multiple choice, but you'll get something that will look like that. Okay? So it's in 2 parts. So all that it's going to give you is what's here in blue. You're going to have to do the rest of this. Okay? Do we understand that? All right, let me take a look at any other questions through here. See what else is missing. Okay. You should be able to write an equation, convert it to slope-intercept form, and then graph the equation. Is that one that you want to see done? Do you guys know how to take something that looks like, let's see. You need to be able to convert that to slope-intercept form and then graph it. Can you guys do that? Does anybody need to see that done? Okay. Can you classify a system? Do you guys know what I'm talking about? Okay, so what they're going to do is they're going to give you something like 5x plus 9y, and I'm just going to make up numbers, and -7x plus 2y equals this. Okay? They're going to ask you to classify it. Is it consistent or inconsistent? Is it dependent or independent? Okay? So you need to know consistent, inconsistent, dependent, independent. All right, is this something that we're familiar with enough to be able to get this question right? No. Okay, so there are three types of situations whenever I have two lines, right? I have lines that intersect. I have lines that are parallel. And I have lines that are the same line. Okay? So what I want to determine from this is, do these lines intersect? Do these lines have the same slope but different y-intercept? Two lines that have the same slope but different y-intercept are what? Parallel. Okay? Or are these lines in fact the same line? Okay? Where do we find this information at? Okay, well, we would probably find this well, yeah, so we could graph this, we could solve it, right? We could put it in a matrix. We could even use the Kramer's rule here. Okay? But we have to do one of those things to determine what we know about these lines. I personally would probably put them in the slope-intercept form. Okay? Because that's going to be the most apparent thing, right? If they have different slopes, automatically they cross. Okay, if they have same slopes, different y-intercepts, they're parallel. If they have the same slope and the same y-intercept, then they're the same line. The question is I've got to be able to go back into my notes somewhere and determine, okay, how do I know if it's consistent, inconsistent, dependent, or independent? Okay, well, let's see what lesson that was from. Classifying systems. Look at this awkward silence on the video. Well, I'm not finding it that way. I think it comes up about 5 or 6 times. Oh, I'm in the wrong book too. That's probably why. Here, let's do this for now so we don't have this like big long gap in here. All right, here we go. Are we ready? All right, you have a chart on page 101, but it's lesson 15 if you have your lesson 15 notes, right? Right. All right, so two lines that cross are consistent and independent. Okay, if they cross, consistent, independent. If they are parallel, they are inconsistent and independent. Right? If they are the same line, they are consistent and independent. Hold on, sorry, inconsistent, independent. Wait, I'm looking at the wrong thing. Consistent, dependent. Ugh. Okay, so I don't know if it helps just to shorten it if you know that you're going to do consistent, inconsistent, independent, dependent. If you can remember your cross is CI, your parallel is II. I could probably remember II on parallel, right? Because they're the same letter. CD is a single line. So however you need to remember it, or if you just need to go back and study your lesson 15 chart, that's what you need. Okay, are we good here? Is that enough information for you? Okay, let's see what else is in here. All right, Kramer's rule. There's another subtracting polynomial. You do need to be able to find the determinant of a 3 by 3 matrix. Is that something that we need to work out? All right, we've worked it out here. We've worked it out over on the other board, right? What do we do first? We subtract and then add, right? Subtract and then add from my first set to the second set to the third set. Do you know what I'm talking about? Okay. So you guys are good on finding the determinant of a 3 by 3 matrix. Do you guys know how to use your graphing calculator to test your answer? No? Okay, well then don't use a calculator. Can you simplify an inequality? Okay, what happens if I divide by a negative or multiply by a negative? The sign switches. All right, you should be able to simplify an expression by adding like terms. All right, you've seen that. You should be able to determine from a graph if a graph is a function. What test does it have to pass? Vertical line test. Okay, you should be able to add two matrices. Okay, can you guys add two matrices? Okay. All right, we've done that one. There's a direct variation question. The word problem, they're solving compound inequalities. Whenever we're solving a compound inequality, we do the same thing to both sides, right? So all sides. Do we know what I'm talking about? Okay. You have another solving. You got a number of inequalities in here that you guys need to solve, and that's it. So there's only 18 questions on the test. Okay. So I'm going to send this video out. Hopefully it's enough to get you through 90% of it. Okay? All right.